Would you expect metals or nonmetals to have a higher ionization energy? So we know the trend on ionization energy is up and to the right of the periodic table. So as you go upper and to the righter side of the periodic table, it generally gets harder to remove those outer electrons. It requires more energy. So we know because the nonmetals are toward the right side of the periodic table and metals are on the left side, we know nonmetals are going to require generally more energy to remove those outer electrons and to ionize those atoms. So let's take a look at one of the periods here. Let's just take a look at period 2. That means the second row. And we're going to do that because they're just easier to draw. They have fewer electrons. So let's take the extreme case here with lithium versus neon. And so we can explain why this is the case. So lithium, being number 3, is going to have 3 electrons. It's going to have 2 electrons in its 1s orbital. Right? And they're not in orbits like this, as you know. And it has 1 valence electron in the 2s orbital. Now, when you go all the way to the right, neon has 2 electrons in its 1s orbital. It has 2 electrons in its 2s orbital, and then 6 in its 2p sublevel. So it has 8 valence electrons. It has 8 electrons in its outermost energy level. So the reason I drew it much smaller is because as you go from left to right across a period on the periodic table, the shielding effect remains generally is the same. So for that valence electron for lithium and that valence electron, I could have picked any one of these valence electrons for neon, all right, they're shielded by the same number of electrons, pretty much. Right? This lithium's valence electron is shielded by 2 inner core electrons, and so is neon. Is shielded by 2 inner core electrons. So the shielding is relatively the same for both of those valence electrons. Now the big difference is lithium has a nuclear charge of 3 and neon has a nuclear charge of 10. That's the major factor as you move across the row of the period of the periodic table. And so this electron is seeing like about 1 proton, because these 2 electrons in the core are kind of shielding, or they're having 2 protons to themselves effectively. So this guy out here is seeing about 1 proton. It's like, not much here to see, and it's not going to require a lot of energy to remove that guy. Our electrons are attracted to protons. Now this guy over here is seeing about 8 protons. It's like, wow, there's some good stuff here. I'm not going home. Try to remove me, you can try it. You can. It'll take a lot more energy because it's just so, and not only that, it's also closer to the nucleus where it wants to be, right? Because again, these 2 electrons are the core electrons shielding only about 2 of the 10 protons. The rest is 8. All right, so every one of these valence electrons on neon are seeing about 8 protons. Try to remove any one of them, it's going to be much harder to do. All right, so summarize, shielding effect about the same as you move across the period, but it's the nuclear charge, the Z, that it just increases as you go to the right, and they're just going to make it harder and harder to pull those outermost electrons off.